Hola, ¿qué tal? Hola, ¿qué tal? Iniciamos con una nueva transmisión de que vamos a ver la misión del cohete ATA-5 de la misión USSF-12. El cohete ATA-5 es de la configuración 541. ¿Qué significa? Lo veremos más adelante. Aunque aún no están iniciando la transmisión, estaremos esperando. Vamos ya.
¿Cómo se llama? Sí.
Muy bien, en esto. Muy bien, en este momento dice de que la carga útil de la delantera es el WFOV, es una nave de prueba de informar al programa de infrarrojo persistente aéreo de próxima generación del programa NextGen. Sucederá al programa de sistemas infrarrojos basados en el espacio y está diseñado para proporcionar una capacidad resistente. Entonces se trata de un satélite de que detectará lanzamientos de misiles de otras naciones. De la NASA dice que se basará en una serie de plataformas asequibles AQUILA M8 y banco Centro de la Observación Transformacional de 6 lados de desarrollo de bajo un contacto separado. La carga última es para un propulsor llamado USSF-12 Ring, línea de la misión clasificada para demostrar tecnología futura para el Departamento de Defensa. Así es, USSF-12 y esta misión es totalmente financiada por la ¿cómo se diría? Por la Fuerza Espacial. Muy bien, vamos a ver. Entonces lo que va a pasar después del lanzamiento, de que a menos un segundo se enciende el motor, los motores RD-180, los motores rusos, de que por el momento no sabemos qué es lo que pasó. A más un segundo ya se encienden los 4 propulsores laterales y con el lanzamiento. A 57 minutos se produce la máxima presión aerodinámica, el Mach 1, donde se consigue A T menos ya los 1 minuto y 48 segundos se hará la separación de los propulsores laterales. Y a los 3 minutos con 25 segundos se hará la separación de las cofias de la carga. Dice que a los 4 minutos y 24 segundos se hará el apagado de la etapa Atlas, el Booster Engine Cutoff o Banco. Después se hará la separación del Atlas y Centaur, y ya el Centaur en ese momento se hará el encendido del motor. Mientras tanto que después de los bueno, ya digamos a los 11 minutos se hará el apagado del motor principal del Centaur, el Main Engine Cutoff o MICO. Dice de que solo nos pueden enseñar unas partes porque la trayectoria, el lanzamiento consistirá con el Centaur que haga como mínimo 3 encendidos. Me dicen que esta misión va a durar como mínimo, lo de 7 horas, 6 minutos y 41 segundos cuando ya se separa la última parte y la desintegración de la etapa Centaur. Aquí vemos de cómo se hacen los procedimientos de la carga, del ensamble. Aquí en cada país nos están diciendo de qué parte se sale. Mientras aún estamos esperando, no sabemos qué podrá pasar. No sabemos. No sabemos. Vamos a ver el video de cómo será la misión. Ya se los dije por mi parte y ahora vamos a ver.
The RD-180 main engine and 4 solid rocket boosters ignite to lift the Atlas V rocket away from the pad. Together, the main engine and SRBs generate a combined liftoff thrust of 2.25 million pounds, or about 10 meganewtons. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path, while minimizing the dynamic pressure the vehicle experiences during flight. The Atlas V reaches Mach 1, the speed of sound, at 35 seconds. 1 minute 48 seconds into flight, the first 2 GEM 63 solid rocket boosters are jettisoned. The remaining 2 are jettisoned about 3 seconds later. Approaching payload fairing jettison, the Atlas V rocket is burning propellant at a rate of 1,700 pounds, or 790 kilograms per second, traveling more than 8,500 miles, or 13,700 kilometers per hour, and located 72 miles, or 117 kilometers in altitude, and 156 miles, or 252 kilometers downrange. During ascent, the spacecraft are protected inside a 5-meter diameter payload fairing. This two-piece shell encapsulates both the Centaur upper stage and both spacecraft. At approximately 3 minutes 25 seconds, the rocket is climbed above the densest part of Earth's atmosphere, and the payload fairing is jettisoned. 4 minutes 24 seconds into flight, propellant levels are depleted, and the main engine shuts down. 6 seconds later, the Atlas Centaur separation system activates to release the booster stage. The rocket now weighs a little more than 5% of what it did at liftoff. At 4 minutes 40 seconds, the first Centaur main engine burn begins.
Después de la separación,
Following a 12-minute 15-second coast, the second Centaur main...
You have ignition. You have permission to launch.
Ya está iniciando.
Liftoff. Liftoff of the United Launch Alliance Atlas V rocket.
Mach 1, execute. And we have an indication of spacecraft separation.
Good evening. I'm Andrea Linhoff. I'm a systems engineering lead at ULA and your host for tonight's Atlas V USSF-12 launch for the United States Space Force Space Systems Command. I'm here at ULA's Atlas Spaceflight Operations Center at Cape Canaveral Space Force Station in Florida. Liftoff is scheduled for 6 p.m. Eastern, though we do have a 2-hour available today. In addition to watching our webcast, you can also follow live mission progress at ulalaunch.com. The count is currently in a 30-minute planned hold. We have 2 planned holds in our 7.5-hour launch count, which give our team additional time to resolve any issues prior to entering the terminal count. At this time, the team is not working any issues and we are proceeding towards an on-time liftoff. Today's ascent to geosynchronous orbit is more than 6 hours, so we'll wrap up 25 minutes after liftoff.
Muy bien.
Stay tuned after liftoff to hear more about Wide Field of View from U.S. Space
Pues al
Forces,
parecer estoy
Colonel
viendo
Heather
que
Boxty, and
si
Millennium
tú por
Space Systems
Liftoff
CEO Jason Kim.
dicen de que al parecer ya
Before we
estamos a
continue, let's check in on
18
today's weather
minutos para el
forecast with
lanzamiento.
Space Launch Delta 45 Weather Officer Will Ulrich.
Thanks, Andrea. Good things come to those who will wait. That's the saying, right? Well, unfortunately, it looks like we're going to have to wait a little bit longer as Mother Nature isn't entirely cooperating right now. My colleagues at the 45th Weather Squadron are actively evaluating those 10 lightning launch commit criteria to ensure we keep that rocket safe from both natural and rocket-triggered lightning. And one of those rules, the attached anvil cloud rule, is currently being violated. However, there are signs that those clouds are beginning to clear over the pad, and we will be in a go situation just before T0. But we'll continue to evaluate those clouds all the way up until the final few seconds of the count. Now, a live look at satellite imagery behind me shows those widespread clouds cover across the spaceport. Showers and thunderstorms are well west of Complex 41, and the clouds that you see over Cape Canaveral right now are beginning to thick thin. So that's why we're very confident going into the look. We do look good. Jessica Williams just gave her final weather brief at L-30 minutes and gave a 60% chance of go or 40% chance of no-go conditions due to the cumulus cloud and attached anvil rules. Now, although Mother Nature isn't cooperating right now, we do expect her to cooperate here shortly, and we should be good to go with the opening of the window. Andrea, back to you.
Thanks, Will. Wind can play a critical role on launch day. ULA has a team of engineers making sure we maximize our launch opportunities with real-time wind monitoring and trajectory updates. To learn more, we spoke with Robert Olson.
I'm Robert Olson. I work at the Structural Dynamics Group here at ULA, and I'm responsible for the execution of operations here in the Denver Winds Room. We call it the Winds Room because we're monitoring the balloons that are released from the launch site, and they're measuring the winds aloft for us. And as part of that, we develop a steering algorithm for the vehicle to steer into the wind to minimize vehicle responses. And we're also verifying that the vehicle is structurally capable and can control itself flying through the wind. The team of engineers shows up here about 4 hours prior to launch. We have our first balloon release. We're trending the winds aloft conditions on launch day. And for each of those balloons, we see, is the vehicle structurally capable and can it control itself flying through those winds aloft? And what are the performance impacts from flying through those winds aloft? It's critically important for these low margin, high performing type of systems that we have a very deep understanding of exactly what the vehicle is going to experience. And in so doing, we're increasing our reliability and the confidence that we have in what the vehicle is going to experience. And we're going to ensure that the vehicle is not going to fail in the very dynamic lower portion of the atmosphere on its way to orbit. What is unique about this operation here in the Winds Room as well is that we are extremely agile in what we're doing because we have the capabilities to adapt to later balloons in the air and still meet our timeline for whatever T0 the entire launch team is working. It's very important for us here to balance reliability and launch availability. Reliability would be having the most amount of margin possible and protecting the vehicle in that way, while that would be in direct conflict with being able to launch at any given time. So we're balancing that here with the way that we operate with the balloons. We have many balloons in succession, very close to liftoff, and that allows us to provide that balance of launch availability.
Just as we went on air, the hold was extended. We will be unable to enter terminal count as the appointed time at 6:00 p.m. Eastern liftoff time. ULA is launching USSF-12 for the Space Force's Space Systems Command. Let's learn more from Government Mission Integration Manager, Lieutenant Paige Harrison.
USSF-12 features 2 satellite payloads, the Wide Field of View testbed as well as the USSF-12 Ring. Atlas V will deliver both spacecraft directly to geosynchronous orbit, approximately 22,000 miles or 36,000 kilometers above the equator. The forward payload, Wide Field of View, is a testbed spacecraft that informs the next-gen overhead persistent infrared program, the successor for the Space-Based Infrared System program, or SBIRS for short. Designed to provide a resilient space-based global missile warning capability against emerging missile and counter-space threats. Wide Field of View's primary mission is to explore future missile warning algorithms with data collected in space. The aft payload is a propulsive ESPA called the USSF-12 Ring. This ring is a classified mission to demonstrate future technology for the Department of Defense.
For today's launch, ULA is using an Atlas V 541 rocket. This is the 94th Atlas V launch and ULA's 151st launch. Produced in ULA's 1.6 million square foot production facility in Decatur, Alabama, the Atlas V Common Core booster is powered by an NPO Energobosch RD-180 engine. 4 Northrop Grumman solid rocket boosters provide additional thrust at liftoff. The Centaur second stage is powered by an Aerojet Rocketdyne RL-10 engine. The 2 spacecraft are encapsulated in a 5-meter diameter payload fairing produced by Beyond Gravity in Decatur, Alabama. These rocket components travel from Alabama to Cape Canaveral on ULA's rocket ship. Once in Florida, a series of events lead to today's countdown. We're here outside the Vertical Integration Facility, or VIF, at Space Launch Complex 41, where we're about to launch 5 on the Mobile Launch Platform, or MLP, to the pad. Before we do, let's take a look at how we stack this rocket. Our process began with lifting the 107-foot or 33-meter booster onto the MLP. Then the team mated the SRBs to the booster, followed by the transportation and lift of the Centaur into position atop the Atlas V booster. Finally, the payload fairing with both spacecraft already encapsulated was mated to the Atlas V rocket. With the rocket fully assembled, we now transition to the final countdown procedure by rolling it from the VIF to the pad. To complete this move, 6 components are used for the 20-minute trip, which spans about 1/3 of the road. The MLP weighs approximately 2 million pounds, supports the rocket, and contains air conditioning, electrical, and commodities. The undercarriages bear the weight of the MLP in the rocket. The Atlas V rocket stands 196 feet, or about 60 meters, and weighs 775,000 pounds, or more than 350,000 kilograms fully fueled. With the rocket on the pad, the launch team transitions to fueling and other final preparations. We have an update on the weather. I'm going to hand it back to Will for a status.
Muy bien.
Hey, Andrea. Just wanted to give a quick update because I just heard from my colleagues at the 45th Weather Squadron over at the Morrell Operations Center that the estimated clear time on that one rule that we've been monitoring, the attached anvil rule, is going to last a little longer. So we are going to have to eat into today's window. And those clouds that you see over the spaceport are remaining a little bit thicker than we originally anticipated. So that attached anvil cloud rule is not expected to clear until 6:15 p.m. local. Now, we still anticipate going into a go situation here shortly thereafter. So we still have plenty of time within that 2-hour window to get today's launch off the ground. Back to you.
Está actualizado y al parecer estamos a T-10
ULA's Atlas V 541 rocket is launching both spacecraft to geosynchronous orbit. Let's learn more about today's flight.
The RD-180 main engine and 4 solid rocket boosters ignite to lift the Atlas V rocket away from the pad. Together, the main engine and SRBs generate a combined liftoff thrust of 2.25 million pounds, or about 10 meganewtons. The Atlas V reaches Mach 1 at the speed of sound at 35 seconds. 1 minute seconds into flight, the first two GEM 63 solid rocket
Antes de
boosters are
los 2 minutos se hará la
jettisoned. The remaining
separación de
two are
los 4
jettisoned about 3
propulsores
seconds
laterales
later.
de combustible sólido.
At approximately 3 minutes 25 seconds, the rocket is
De que a
climbed
los 3
above the
minutos y
densest part
25
of Earth's
segundos se hará la
atmosphere, and the payload
separación de
fairing
las
is jettisoned.
bogias.
4 minutes 24 seconds into flight, propellant levels are depleted, and the main engine
De
shuts
que
down.
después se hará la
6
separación de
seconds
la
later, the Atlas Centaur
el
separation
propulsor
system
Atlas,
activates to release the booster
que
stage.
se hará la
The rocket now
separación
weighs a
del
little
Atlas
more
con
than
el
5%
Centaur,
of what it did
será
at
después
liftoff.
el motor
At 4 minutes 40 seconds, the first Centaur main engine burn begins.
Centaur,
Following a
main
12-minute,
engine
15-second coast, the second Centaur main engine burn begins. Within this
unos
sequence,
minutos
the
después se
second
hará
burn is used to raise
el
the
apagado,
aperture to
se
enable
hará
the
el segundo
smooth
encendido.
5 hours, 43 minutes, 54
Y
seconds
que
after
después de 5
liftoff,
horas se
the
hará el
RL-10 engine
otro
ignites for the
encendido
final burn.
para ponerlo ya en órbita.
Nearly 2.5 minutes later, Centaur completes its final engine cutoff following a guidance
Unos
commanded
minutos después se
shutdown.
hará el apagado, pero eso no
The
lo
first
podemos.
of 2 spacecraft separations occurs at 5 hours, 49 minutes, 36 seconds,
Se dice
releasing
que
a
primero se
wide
separará
field of
el
view of the
satélite.
Space Force's Space Sensing Directorate. At 5 hours, 59 minutes, 3 seconds, Centaur releases the booster adapter. 6 hours, 5 minutes, 21 seconds after liftoff, Centaur releases the USSF-12 Ring
Entonces
spacecraft
serán
for the
3
Space
cargas que se
Systems Command
separarán.
Innovation and Prototyping Directorate.
En estos momentos estamos a 2 y 30 segundos. Para que ya en 4 segundos ya se active atrás de la transmisión. Lo que se espera. Solo falta la verificación final del lanzamiento. Alguien nos enseñó de una parte de cómo va la construcción de la torre de lanzamiento para la Starship. Menos y 30 segundos.
ULA's Vulcan rocket is nearing its first flight. While we're waiting for a new T0, let's get an update on Vulcan.
Vulcan Centaur production begins with aluminum sheets, expertly machined to remove more than 2/3 of the weight, resulting in the structurally strong yet lightweight orthogrid panels that form Vulcan's propellant tanks. The panels are then bump pressed to form the curves required to complete the tanks. At the same time, rings, adapters, and other structural components are precision milled. Next, The aluminum domes, panels, and other structures that form Vulcan's propellant tanks are first cleaned and etched to a smooth, even surface, and then anodized to harden and prevent corrosion. Following an ultrasonic inspection, 5 completed panels for the liquefied natural gas, or LNG tank, are assembled and joined together using friction stir welding. Unlike traditional welding, where filler materials are used to join components, friction stir welding uses a head to stir the metal of the 2 panels together as it moves down the seam. The resulting joint is stronger and produces a lighter weight, higher performing tank. The process is repeated to create the liquid oxygen, or LOX tank, followed by attaching domes to complete the tanks. Circumferential friction stir welding is then used to join the 2 propellant tanks that comprise the Vulcan booster. As production continues on the booster stage, stretch-forming gore panels for the Centaur's second stage propellant tanks is underway. The stainless steel gore panels are welded together to create the propellant tank domes. The gore welder is one of several highly specialized welding stations in the Centaur production process. Just down the aisle, Centaur 5's massive intermediate bulkhead is mated to its ultra-thin tank. Once both propellant tanks are welded, they're mated together to create the Centaur 5 second stage. Once the propellant tanks are joined, the 5.4-meter booster is sprayed with foam insulation before moving to final assembly. Twin BE-4 engines are hot-fired and then mated to Vulcan's thrust structure. With production complete, the booster makes its way onto ULA's rocket ship for its journey to the launch site. Meanwhile, Cape Canaveral's Space Launch Complex 41, the water suppression system has been upgraded and tested, along with other modifications, including new, larger fuel storage tanks. In the Vertical Integration Facility, or VIF, platforms have been modified to accommodate the larger Vulcan rocket. Following the 8-day journey to Cape Canaveral, the booster is offloaded and transported to the VIF, where it is lifted onto the newly constructed Vulcan Launch Platform, or VLP. The first Vulcan booster then travels a third of a mile to the pad for testing, followed by 2.7 miles to the Spaceflight Processing Operations Center, or SPOC, for additional testing. This launch site testing culminates with another trip to the pad, where the LOX and LNG tanks will be filled and chilled to flight levels and temperatures.
Dice de que aún está manteniendo extendido, ¿no? Porque aún no pueden ingresar el conteo de las terminales y dice que la hora de estándar que puede ser lanzamiento es a las 6 p.m. dentro de 2 minutos.
Reflecting a wide field of view as seen through a wasp's eyes. Additionally, there are 2 black stars inside a red plume to represent the 2 space vehicle programs.
Y miren, lo tengo mi cohete mi cohete electrón de la misión. Editado por mí mismo. Aún no se sabe hasta cuándo se va a lanzar. Estamos en la cuenta oficial de United Airlines. Así que aún tenemos que esperar. Mientras tanto, voy a estar por unos momentos sin comentar.
In addition to monitoring the Anvil cloud rule, we are also monitoring wind. As we learned in the earlier video, a series of weather balloons has been launched throughout the countdown from the range weather station at the Cape to collect measurements of wind speeds and directions to determine if conditions aloft violate the controllability or structural loads on the rocket during ascent. The balloon data is transmitted to ULA engineers in Denver to select a steering profile that minimizes launch vehicle responses. ULA builds Atlas, Delta, and now Vulcan rockets in a 1.6 million square foot facility in Decatur, Alabama. Here's a look inside.
Successfully launching missions to every planet in the solar system, in addition to critical national security, science, weather, and communication satellites, ULA has established a long-standing industry reputation for reliability and orbit accuracy. While our rockets lift off from launch pads in Florida and California, the journey to space begins in Decatur, Alabama. At approximately 1.6 million square feet, ULA's production facility is an always-on workhorse where technicians simultaneously build components for Atlas V, Delta IV Heavy, and Vulcan Centaur rockets. Booster production begins when large aluminum plate stock is loaded into one of 4 double gantry skin milling machines, where aluminum is milled into patterns designed for building tanks and other components. This process helps reduce the original weight of each panel by 70%, while maintaining approximately 75% of the original material strength. After machining, skin panels are transported to the brake form and bump pressed into the precise curved radius required to create fuel tank barrel sections. Components made from aluminum require anodization to protect from corrosion. For this requirement, certain components, like skin panels, are first given a high-pressure wash and then dipped in a series of chemicals to complete the sealing process. Skin panels are then transported to the vertical friction stir welder, where they are lifted and forged together to form the barrel sections of the fuel and oxidizer tanks. Delta IV and Vulcan Centaur tanks are comprised of 5 skin panels, while 4 skin panels form the Atlas V tanks. Friction stir welding is a unique process accomplished by a pin tool, which applies frictional heat and stirring of the parent material to form a weld. This process only uses friction as the heat source and has no filler material, making an extremely strong welded joint. Completed aluminum barrel sections then move to the circumferential friction stir welder, where domes are welded to each end, completing the first stage fuel tanks. After pressure testing, which verifies the integrity of the welds, the next stop for booster fuel tanks is the spray-on foam insulation booth, or SOFI. This is where completed tanks are primed, then insulated to protect from the acoustics that occur at liftoff. Tanks then move to final assembly, where components like wiring and engines are added. In addition to the first stage, or booster stage, ULA's second stages are also built in Decatur. The factory has recently undergone a major reconfiguration, resulting in a new state-of-the-art Centaur V production line to increase the speed at which Vulcan Centaur second stages are built, assembled, and tested. The Centaur upper stages for Atlas and Vulcan are built using a thin stainless steel structure, making it the most efficient upper stage currently in use. To create the domes or bulkheads for Centaur's 2 tanks, gores or pie-shaped sheets are welded together. The bulkheads and tank skins are then assembled using a combination of spot and seam welds. Spray-on foam insulation, or SOFI, is then applied to the Centaur tank to provide thermal protection for the cryogenic fuels. Centaur's tanks are known as pressure-stabilized tanks because 90% of their weight and structure at launch is from the mass of the fuel and oxidizer loaded prior to liftoff. The Centaur tank then moves to final assembly, where engines, avionics, pneumatic, and propulsion systems are installed. At the end of the production journey, all systems on both the booster and Centaur are fully tested, and the stages are prepared for transport to the launch site. With testing and transport preparations completed, Atlas V, Delta IV Heavy, and Vulcan Centaur rockets exit the factory and roll about a mile down the road to a dock on the Tennessee River. Once loaded onto the RS rocket ship, ULA's specially designed cargo boat, the rockets begin the 8-day trip to Cape Canaveral Space Force Station, Florida, or the 23-day trip to Vandenberg Space Force Base, California.
The launch team continues to track both issues. Anvil clouds remain unacceptable for flight, and the most recent upper-level wind reading was red. Let's get an update from Will Ulrich.
Thanks, Andrea. The waiting game continues. First, let's talk about the attached anvil rule. Live look at satellite imagery right now continues to show upper-level clouds streaming over the spaceport. And those clouds, although they are thinning, they remain situated directly over Complex 41, so they're taking a little bit more time to get out of the way. With that in mind, my colleagues at the 45th Weather Squadron have updated the estimated clear time to no earlier than 6:30 p.m. this evening, so we're going to have to wait a little bit longer. Additionally, upper-level winds are currently unfavorable, and it's not that those winds are particularly strong, because at this time of year, winds are typically very light from the surface all the way through the upper portions of the atmosphere, but they are variable. So flight teams in Denver and with other units inside of United Launch Alliance are keeping a close eye on the changeability or variability of those wind speeds to ensure that the rocket makes the correct adjustments as it moves up into the atmosphere. So with that said, we're not going to go any earlier than 6:30 p.m., but the general trend is our friend. Is our friend as those clouds continue to thin and move out of the way. We'll provide an update as soon as I have one. Back to you, Andrea.
Thanks, Will. This May, ULA lifted the Boeing Starliner capsule for NASA, marking our 150th launch since our doors opened in 2006. Let's take a look at some highlights commemorating this milestone.
150. 150 consecutive launches. 150 consecutive successes. At ULA, 100% mission success is an to the most complex geosynchronous orbits and interplanetary trajectories. ULA is the only launch provider capable of delivering to any orbit, anytime. 30 Delta IIs, 23 Delta IVs, 12 Delta IV Heavies, 85 Atlas Vs. 150 flights using our trusted fleet of rockets built to the evolving needs of each and every customer. We've traveled 2,500,000 miles and delivered more than 1,400,000 pounds to orbit. Deliveries that have improved the way we live and work and provided a deeper understanding of our universe. All rockets are not created equal, and when it absolutely must get to space safely and on time, customers choose ULA. 150 glorious liftoffs, 100% mission success.
We often get questions about the various clock displays visible in the Launch Control Center, most notably the T count and the L count clocks. T simply stands for time, and L for launch. The T count is a scripted time until T0. All of the launch vehicle countdown events are procedurally sequenced to T time. The L count is the total amount of time until launch, which is the T time plus the built-in holds. Built-in holds are placed at strategic points in the countdown. For instance, before cryogenic loading and before the terminal count and liftoff, and are contingency time that the team can use if needed to catch up in the event of a delay in countdown activities.
LC, LD, channel 1.
Go, LD.
LC, load contingency address file, adjust underscore AB094 underscore 07, SDLCRC 511 Delta.
Roger, AB094 underscore 07, 511 Delta. Flight control, LC. Go ahead, this is flight control. We have a go to load contingency file, adjust underscore AB094 underscore 07, SDLCRC 511 Delta. And work.
We have another update on the weather. I'm going to hand it back to Will Ulrich for a status.
Hey, Andrea. It's like we keep pushing the snooze button waiting for tonight's launch, right? I have a little bit of an update from my colleagues over at the 45th Weather Squadron. Satellite imagery continues to show that anvil cloud sitting overhead, and this live shot that you see right now shows that anvil cloud perfectly over Complex 41, and unfortunately it just doesn't want to move. Now originally we were evaluating that cloud under the attached anvil cloud rule because it was attached to its parent thunderstorm. That thunderstorm has since dissipated, so we're now evaluating it under the detached anvil cloud rule. Unfortunately, that doesn't really change the status that we're in. We are in a no-go status for the detached anvil rule with an updated clear time of 6:45 p.m. So we still have at least another 15-20 minutes to go before we can start thinking about setting that new T0. So that's all I've got for now. I'll throw it back to you in the studio.
Thanks, Will. Wondering how you can see today's Atlas V launch of USSF-12? This visibility map shows when and where your best chances are to see the rocket as it launches from Cape Canaveral. While we are still waiting to clear the Anvil cloud rule, a new upper-level wind profile has been loaded into the Atlas V rocket's onboard computer, and the upper-level winds are now green. I'm going to toss it back to Will Ulrich for more details on the weather.
Hey, Andrea, that's great news about the upper level winds. Now that means all that we're left with is continuing to monitor the detached anvil rule. And I wanted to bring up GR Analyst, which is one of the tools that we use at the 45th Weather Squadron to evaluate current radar imagery. Now what you're looking at right now is called radar reflectivity, and it shows the cloud of concern at approximately 20 to 30,000 feet. This is that detached anvil cloud rule that my colleagues at the 45th Weather Squadron are actively evaluating. The 45th Weather Squadron are actively evaluating. Now the good news is that that cumulus cloud is detached anvil cloud is beginning to dissipate. If I put it forward into time, notice how that cloud is gradually thinning out, and that's what we need to look for in order to get us out of that detached anvil rule. So I do expect an update from my colleagues here soon. We may be able to clear that detached anvil rule for much longer, and really, if we're green on upper level winds, we're not really concerned with anything else at this point, and I do think we have a shot to launch later today. Back to you.
Muy bien, muy bien, muy bien. Muy bien.
Vamos a
Muy bien. Al parecer el lanzamiento está programado a 1 hora para dentro de 15 minutos porque dice que las nubes de Yunque ahora no se espera que se despejen hasta dentro de 16 minutos. Así que aún tenemos que esperar para el lanzamiento.
We have another weather update. I'm going to send it over again to Will Ulrich.
Hey, Andrea. Just heard from my colleagues at the 45th Weather Squadron over at the Morale Operations Center, and we are extending the no-go status on that detached anvil cloud rule for a little bit longer. And one of those reasons is because that cloud, though it is dissipating, it's still above the limit that we monitor to ensure that cloud does not pose a threat for rocket-triggered lightning. So the clouds that you see there over Cape Canaveral are moving in the correct direction. They are slowly moving from the west to the east, and even though they're moving very slowly, they're also dissipating at the same time. So long as we continue to see that trend, and we still have about an hour and 10 to an hour and 15 minutes left in the window, the trend is our friend, and we're hopeful that that cloud will get out of here in time so that we can launch just after 7 p.m. I'll provide an update as soon as I hear. Back to you guys.
LC, LD, Channel 1.
Go LD.
Please coordinate a new T0 with the range 231500Z.
Roger, 231500Z. Set the clock for 23.
Muy bien, ahora seguimos.
T0.
Roger.
RC, LC.
RC on 1.
Please coordinate with the range, new T.
Bueno, ya.
¡Tu chillón! ¡Ey!
LC countdown clock has been set for new T0 of 23:15 Zulu.
Bueno, ya.
Clock is at L-23 and counting.
Roger. All right, for a team, we'll pick up at L-16. CT1 start to
¿Está bien?
max at that time.
LC, RC, net 1.
Go RC.
The range has approved our new T0 time of 23:15:00Z.
Roger. All right, team, T0 is approved. And we are counting.
Muy bien, ya tenemos la hora de lanzamiento.
L-23 minutes.
As you just heard, a new T0 has been set for 7:15 p.m. Eastern Time.
Muy bien, vamos a estar esperando para el lanzamiento, de que dice que ahora el lanzamiento está programado para dentro de 20 minutos aproximadamente, ahora sí, de que la nueva hora de lanzamiento. Pues sí, en Twitter dice de que nueva hora de lanzamiento. El director de lanzamiento James Wayne ha dado instrucciones al equipo para que coordine una nueva hora de lanzamiento a las 7:15, sería aquí las 6:15 hora de México, el lanzamiento.
L-21 minutes.
We've created a short tour of our launch locations here in Cape Canaveral, Florida. Let's take a look around.
With missions launched to every planet in the solar system, as
Nos
well as
están
critical
enseñando
national
más
security, science,
videos
weather,
sobre
and communications
United Launch
satellites,
Alliance.
ULA has established a long-standing reputation for reliability and orbit accuracy in the space launch industry. At our launch site in Cape Canaveral, Florida, the story begins with ULA's Atlas and Delta rockets
Hasta que
arriving on
por
the
fin
RS
habrá
rocket ship.
lanzamiento.
The rocket ship is a specially designed cargo ship used to transport rockets from ULA's 1.6 million square foot production facility in Decatur, Alabama. Rocket ship is large enough to carry a complete Delta IV Heavy rocket. That's 3 boosters, a second stage, and a payload fairing. Once loaded, rocket ship departs ULA's dock and travels through the Tennessee River, then onto the Ohio and Mississippi rivers, then goes out into the Gulf of Mexico. From there, the ship travels through the Atlantic Ocean, around the southern tip of Florida, and
Ahí nos
north
está
to
dando el
Cape
recorrido
Canaveral.
de que dice que
Rocket ship
pasa
was
por el
designed
Golfo
with
de
several
México
features to ensure
para
successful
cuando,
delivery,
bueno,
including the
todos
ability
los
to
barcos
adjust
de
its
que
draft
pasan,
for shallow water and
llevar
rudderless
todas las
steering,
etapas de
which
los
minimizes
cohetes
the need to tug.
los
Atlas
cohetes
5 boosters
Atlas
are
y Delta
transported from the
4
ship to
Heavy
the high
en
bay
Cabo
in the Atlas
Cañaveral y
Space
hace
Flight
lo
Operations
mismo, pero
Center,
pasando
or
por el
ASOC, for
canal de
final
Panamá para
preparations.
dirigirse
Delta IV
hacia
boosters are moved
Vandenberg.
to the Horizontal Integration Facility, or
Ahí nos
HIF,
enseñan
where
de
they are
cómo
mated
envían los
together to form the Delta
propulsores del
IV Heavy configuration. With
Delta
final
4
checks
Heavy.
completed, the boosters are
Y ya esos
transported to the
3
launch pad
propulsores
for
de
Launch
Delta 4
Vehicle on
Heavy ya
Stand,
se los
or LVOS. The
y los
7-foot-long
Atlas se los
Atlas
llevan a
5
las
boosters are brought to Space Launch
hangares
Complex
para que
41
se
and
puedan
hoisted into a
ensamblar,
vertical
o en este
position
caso
using a
los
crane
edificios
and
de
placed onto the
ensamblaje.
mobile launch platform P in the Vertical Integration Facility, or VIF. Delta IV Heavy rockets are raised vertically by a fixed pad erector at Space Launch Complex 37. The fixed pad erector uses a single hydraulic piston to rotate the boosters 90 degrees inside the mobile service tower, or MST. LVOS is followed by the addition of solid rocket boosters, and then the second stage. Next comes wet dress rehearsal, or WDR, which is an end-to-end launch simulation, from fueling through spacecraft separation. Meanwhile, the ULA team is also working simultaneously to help the customer encapsulate their payload into the rocket's payload fairing. The encapsulated payload fairing is the final piece to be mated to the rocket. With the rocket stack complete, the spacecraft team tests all of the interfaces with the rocket and the launch pad. Once the rockets are completely assembled, final launch preps begin. For Atlas V rockets, launch countdown begins with moving the rocket from the VIF to the pad. The quarter-mile trip uses 6 components to complete the 20-minute trip. Weighing in at about 2 million pounds, the MLP supports the rocket and contains air conditioning, electrical, and commodities, while the undercarriages bear the weight of the MLP and rocket. 2 rail cars lead the move, with the payload van providing communication to the payload, while the ground van houses the ground support for the rocket. At the rear of the convoy, the portable environmental control system provides air conditioning to the payload and rocket. Finally, track mobiles provide the power to move the 3.5 million pound convoy. For Delta IV Heavy rockets, the process looks quite different. Approximately 9 hours before T0, final preparations begin as 40 hydraulic cylinders at pressures nearing 3,500 psi move the 10 million pound MST. It's first raised 8 inches and then rolled back. Delta uses a carriage transporter system, traveling at about a quarter mile per hour. It takes about 25 minutes to roll the MST to its launch position, 345 feet north of the Delta IV rocket. The Delta IV rocket stands 217 feet tall, or about 21 stories, and weighs more than 900,000 pounds fully fueled. On the day of launch, nearly 30 engineers and managers are polled for system status and readiness to proceed.
Status check to proceed with terminal count, Atlas systems, propulsion.
This is the final status check before launch for all Atlas and Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants.
Range coordinator. Clear to proceed. Launch director.
Ahí nos pedimos de la verificación final del lanzamiento.
This is the mission director. You have permission to launch.
Proceeding with the
Dice de
count.
que ya
If the
todas
rocket
las
is ready for flight
fases
and
de
the weather is
lanzamiento
within the
nos
launch
han
commit
dado el
criteria,
go
then polling
listo
will
para
be
el
completed,
lanzamiento.
and the team will have given the go for launch.
T-minus 10, 9, 8, 7, 6, 5, 4,
Ahí
3,
tenemos una muestra de
2,
lanzamiento de
1.
la
There's
5.
ignition.
Aunque ya he visto muchos lanzamientos, me acuerdo que mi primer lanzamiento que he visto en vivo de la 5 fue
For a
de
typical
la
Atlas V
misión
flight, the main engine and
Starliner
solid rocket boosters
OSPT-1
ignite to lift the rocket off the pad.
2019.
Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path,
Y esto
minimizing the dynamic
atento
pressure the
del
vehicle
lanzamiento de la
experiences during
misión MARS
flight. Within the
2020
first
del
few minutes of flight, the vehicle reaches
el
Mach
rover
1, the speed of
Perseverance
sound,
y el
followed by jettison of the
Ingenuity.
solid rocket boosters. About 4 minutes later, propellant levels deplete and the booster engine shuts down, followed by release of the booster stage. At various times in flight, depending on the mission, the vehicle jettisons its payload fairing. From there, the second stage will continue carrying the spacecraft towards its destination with planned engine starts and stops. Finally, Centaur will release the spacecraft in its target orbit to continue its journey.
Estamos a menos 15 minutos para el lanzamiento.
We have an update on the weather. I'm going to hand it back to
Dice de
Will
que
for
ya
the
todo
status.
está en code, listo para
Hey,
el
Andrea,
lanzamiento.
some really good news. Those clouds that you see on satellite behind me continue to thin, and I just got word from the meteorologists over at the 45th Weather Squadron that we are now go for the detached anvil rule, and that means we're go on all Lightning launch commit criteria. So good news, we are progressing well towards that 7 p.m. liftoff time. All things are go from weather. Back to you guys.
Otra vez tenemos las imágenes tanto de la plataforma de lanzamiento 41 y la torre de la Starship que aún se está ensamblando.
_08 with an SDL CRC of 97 Charlie Charlie.
Roger. Flight Control LC. Go ahead, this flight control. Low contingency file adjust AV094_08 with SDL CRC 97 Charlie Charlie. Roger and work.
Corrección, al parecer el lanzamiento es dentro de 27 minutos.
L-13 minutes. And for a team, we will hold off on IFPS transfer to L at form that at L-9 minutes.
Voy a actualizarlo. Y aún está término no, go for está a términos 27 minutos. Y ya es posible que durante esta tarde o durante la noche ya el cohete Space Launch System o el LSS ya parte de nuevo hacia el edificio de ensamblaje para que le hagan los últimos preparativos para el lanzamiento. Algunos dicen de que se puede lanzar entre agosto y septiembre, porque en julio es imposible, tanto un mes para preparar todo el cohete, poniendo las preparaciones finales.
Dr. Vladimir
Y aún
Shobnov
sigue
was
también
directly
compitiendo
involved in the
con
creation and modifications of
el
rocket engines
Starship
for
y el
much of the
Super
latter
Heavy.
Soviet period, and has long been considered the father of the RD-180 engine, having directly supervised its design. This engine has successfully launched all Atlas III and Atlas V rockets, and USSF-12 is the 100th launch of an RD-180 powered booster. Not
Y al
only was he
parecer,
an
como
accomplished
noticias, tenemos
scientist, he
de
was
que
also well
Juan Webb
respected by
está
his colleagues at
contratando de
ULA
los
and by our
vehículos de
customers. His
Terran,
personable nature made him
el Terran,
approachable by all who interacted
bueno,
with him.
el nuevo Terran de que dice que se
Carl
parece
Threlkeld
mucho al
began his career at
Starship
the
porque
rocket
sea
range in
tan
September
igual de
1997,
reutilizable las
a
dos
veteran of the
partes.
Delta II, Delta IV, Atlas V, and Vulcan programs. Carl was an
Dice
inspector
que serán
responsible
para
for
la
the
segunda
integrity of our
generación de
products,
satélites de
the
que se
safety
lo
of our
contrató a
team, and ultimately the
Relativity
satisfaction
Space.
of our customers. Carl always demonstrated professionalism tinged with wit that kept all smiling with his jokes and antics. He never met a stranger. Rochelle Wunderlich began her aerospace career with Pratt & Whitney in 2001. She recently celebrated her 19th year of combined service with Pratt & Whitney and Aerojet Rocketdyne. Rochelle was an outstanding engineer that understood her products and her team. Her efforts at maintaining supplier quality were key to keeping the RL-10 flying successfully for nearly 2 decades. Earlier this year, she posthumously received the Palm Beach County Engineering Council Merit Award. She remains loved by many and will be deeply missed by all who knew her.
All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC. L-10 minutes.
Terminal count briefing. If a condition exceeds a launch constraint anytime after a terminal count status check, the observer shall announce hold on channel 1, identify their station, and briefly state the reason for the hold. Flight control, perform launch on time verification. Flight control. Roger. OSM, place SRB ignition SMA switch in enable position.
LC, this flight control.
Go.
Contingency file adjust underscore AV094_008 with SDL-CRC 97 Charlie Charlie has been verified and loaded into the Inca.
Roger. LD, LC.
LD on channel 1.
Permission to enable IFPS.
Roger, proceed.
L-9 minutes.
Flight control, enable WFOV IFPS report complete.
This is Atlas Mission Control at T-minus 4 minutes and holding.
Tenemos un nuevo
The
tweet.
team is still working towards
Dice
a
de que ahora
7:15
estamos a
p.m.
menos 10
Eastern
minutos
launch.
del lanzamiento del Atlas 5 con la misión USSF-12. Dice que banco de pruebas y el campo de visión amplio ya aprobarán tecnología. Bueno, eso ya todos lo sabemos.
OSM verified
Estamos
the
a
FCO,
menos 10
ROC, and
minutos.
OSM whole fire switches are in the proceed position.
Ready to proceed.
RLM verified red line monitor and vent table are in the correct configuration for terminal count. Verified. RC verified solid radiation acceptable for launch.
Verified.
WFOV IFPS enabled.
Roger. CRTD, begin telemetry verifications.
LC Sierra TD, we can confirm 33.04 volts.
Roger. And flight control looking for your launch on time verification.
Roger, and work.
Minus 8 minutes.
Dice que estamos a menos 8 minutos para el lanzamiento.
We remain in the hold as we continue towards liftoff. In a few minutes, launch conductor Scott Barney will pull the launch team for the final go to pick up the countdown. 29 engineers and managers are pulled for system status and readiness to proceed. This is a final status check for spacecraft and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final polling.
All steps are complete prior to the status check. LC, switch to ready position.
Vamos a escuchar.
Minus 7 minutes.
Status check.
Y a veces las puedo traducir un poco.
Propulsion. Go. Hydraulics. Go.
Dice que el sistema de propulsión ya está listo. Hidráulica ya está listo.
Go.
El combustible ya dice que ya está listo.
Pneumatics. Go.
Dice que Centaur está preparado para el lanzamiento.
Go. Electrical systems.
Dice que el oxígeno y el hidrógeno ya están listos.
Go. RFFTS.
El sistema eléctrico ya está listo.
Go. GCQ. Go. Operation support.
Go.
El control de lanzamiento dice que ya está listo. Soporte, operación de soporte listo.
Go. Quality.
Go.
Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go. Range coordinator. Clear to
Vamos a ver
proceed.
si todo salió con una se aborda la misión completa.
I will hold prior to coming out of the count.
Como que se abortó.
And LD,
Según
LC,
el-
that one.
LD.
Are you expecting to get a clear in the next minute and a half?
Yes, we are. This is the LD. Launch vehicle is ready to launch.
Roger. Mission director.
Mission Director, you have permission to launch.
Proceeding with the count.
Han dado permiso para el lanzamiento. Listo vuelo para el lanzamiento.
Is set for 23:15:00.
Tanto el director de lanzamiento como de misión ya les han dado listo para el lanzamiento.
Is configured for launch.
WFOV is configured for launch.
Polling is complete. The ULA launch team and the Space Force mission director are go for launch. From T-minus 4 minutes until launch, you will be listening to Scott Barney and his team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank levels and pressures in the booster and Centaur, and arming the flight termination system. At T-minus 25 seconds, you'll hear Go Atlas, Go Centaur, Go USSF-12. This is a final status check of Atlas, Centaur, and USSF-12 readiness. At T-minus 3 seconds, the main engine ignites, followed by ignition of the solid rocket boosters. Then after seeing the Atlas V lift off the launch pad, you'll begin hearing flight commentator Patrick Moore providing ascent data as the rocket makes its way to orbit. This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
2, 1, mark. 359.
Transferring ring to internal power.
Roger.
355.
Muy bien.
Pyros enabled.
Ya está la cuenta final, a menos 4 minutos.
The countdown clock is resumed and we are go for launch at 7:15 p.m. Eastern. With liftoff approaching, we're going to raise the volume on our launch team so you can hear the final preps.
Muy bien, aquí vamos.
330.
Atlas hydraulics at flight pressure.
Ahí está, de que ya estaba pasando el efecto del hielo con los combustibles criogénicos, de que eso pasa, de que ya se inician a evaporar y se están condensando en las paredes del cohete. Que eso lo que causa es que está formándose hielo y por eso lo blanco.
3 minutes.
3 minutos.
Atlas tank to flight pressure.
250.
FPS internal.
Muy bien, vamos. Tenemos a 2 minutos y 7 segundos. Dos minutos para el lanzamiento.
Vehicle internal.
155.
Launch sequencer start.
150.
1 minuto 50.
Securing Centaur
Ahí
LA2.
tenemos imágenes del edificio de ensamblaje.
140.
Launch enabled.
137.
T-minus 90 seconds. The launch
Dice
vehicle
que estamos a
payload ground
menos
systems
90
in Eastern Range are
segundos,
go for launch.
1 minuto y medio.
Ring is configured for launch.
120.
1 minuto 20.
OCU's armed.
SCS count started.
115.
Reduce ECS for launch.
Roger.
110.
Vent valves locked.
Muy bien, vamos.
T-minus 1
tenemos.
minute.
Screen.
Vamos a escuchar el Atlas. Están diciendo listo Atlas, listo Centaur y listo USSF-12. Eso pasará a los 30 segundos. Segundos.
28.
Verify ECS reduced for launch.
Verified.
25.
Status check. Go Atlas.
Go
Listo
Centaur.
Atlas, listo Centaur y listo USSF-12.
T-minus 10, 9,
9,
8,
8, 7,
7,
6,
5, 4, 3,
3,
2,
2,
1.
1.
We have engine ignition.
Hay
And
lanzamiento.
liftoff of the United Launch Alliance Atlas V rocket.
Despegue del Atlas 5 del United Launch
USSF-12 for the
Alliance.
United States Space Force.
Pitch over program, body rates look good.
Vámonos. Rápido abandonó la rampa de lanzamiento.
System response looks good. Now 20 seconds into flight. Atlas is now completing the pitch over maneuver. Body rates continue to look good. RD-180 is throttled down slightly to partial thrust. Response looks good.
Va todo bien.
Now 36 seconds into flight. Atlas V is now passing Mach 1. RD-180 continue to
Está
look good in
pasando
partial thrust
por
mode.
la marcha
See good chamber pressures
1.
on all SRBs.
pasando por máxima presión aerodinámica, donde primero se baja la potencia de los motores y después de pasar máxima presión aerodinámica vuelven a aumentarlos para abandonar la atmósfera.
RD-180 now throttling back up to full thrust as expected. Chamber pressures on the SRBs continue to look good.
Ahí tenemos imágenes desde la cámara del propulsor Atlas 5.
Now 1 minute, 23 seconds into flight, approximately 3 minutes now remaining in the boost phase of flight. And at this point in the flight,
ahí ya se ve la
now weighs just
curvatura
1/2
de la
of
Tierra.
a foot top weight. And see SRB chamber pressures tailing off now. And we have SRB burnout.
Ahí vamos. No,
1 minute,
minutos se hará
45
la
seconds into flight.
separación de
RD-180 engine operating parameters continue to look good.
los... Muy bien, en este momento se hace la separación de los propulsores laterales de combustible sólido.
Vehicle's gone to closed loop steering. Body rate responses look good. Just past 2 minutes into flight now. RD-180 throttling down slightly as expected. Engine operating parameters continue to look good. And 2 minutes now remaining in the boost phase of flight. Atlas V is now 50 miles in altitude, 78 miles downrange distance, traveling at 5,000 miles per hour. 2 minutes, 40 seconds in. RD-180 engine operating parameters continue to look good. Vehicle body rates looking good throughout boost phase. And the
Bien,
Centaur
ahí
reaction
vamos.
control system
Después
is
se
now
hará la
pressurizing to
separación
flight
de
level. System response looks
las
good.
cofias.
Coming up on 3 minutes into flight. RD-180 now throttling to maintain a constant 2.5 G acceleration limit, seeing good response on the RD-180. Body rates continue to look good throughout boost phase. Now passing 3 minutes, 20 seconds into flight. Approximately 1 minute now remaining until BECO.
Muy bien, se hizo la separación de las cofias.
And we have good indication of payload fairing jettison and CFLR deck
Sí,
jettison.
ya se hizo la separación de las cofias.
Vehicle's now throttled back up slightly. Engine response continues to look good.
Ahí tenemos
And
las
RD-180 now
animaciones
throttling to
del
maintain a constant
cohete
4.6
Atlas
G
5.
acceleration limit in preparation for BECO. And we have boost phase chill down. Passing 4 minutes into flight. Vehicle systems all continue to operate
Minutos se
normally
hará
throughout
el
boost phase.
apagado del propulsor
Body
Atlas
rates
5
continue to look good.
y
RD-180 engine
empezará a
operating parameters
venir
continue to look good as it maintains
estará
that
en
acceleration
función
limit.
la etapa superior, el Centaur.
Standing by for BECO shortly. And we have BECO booster engine cutoff, standing by for stage set.
Muy bien, se hizo el pico, el boost engine
We have
cargo
good
apagado
indication of
del
stage
propulsor.
separation.
Se hizo la separación del Centaur.
We have pre-start on the RL-10, standing by for ignition.
Se enciende el motor del Centaur.
We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good. Centaur's gone to closed loop steering. Body rates continue to look good. Now 5 minutes into flight. RL-10 chamber pressure continues to look good. Body rates look good. This first burn of today's mission will last approximately 6 minutes, 18 seconds.
This is Atlas Mission Control at T plus 5 minutes and 14 seconds. We just heard flight commentator Patrick Moore confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. Our next event, Centaur main engine cutoff, will occur in approximately 6 minutes. As we approach our next milestone, we'd like to share a recent conversation with U.S. Space Force's Colonel Heather Bogsty.
Hi, I'm Colonel Heather Bogsty,
the Senior
Mientras
Material
tanto, nos
Leader
están
for the
enseñando
Resilient Missile Warning, Missile
otro video
Tracking, and
sobre la
Missile
misión
Defense Acquisition
USSF-12.
Delta from the Space Sensing Directorate, Space Systems Command in Los Angeles Air Force Base, California. At Space Systems Command, we are focused on the threat. And right now, we are at unprecedented times where the threat is coming at us faster than ever, with dimmer targets that we are currently working to detect better. The launch of USSF-12 and Wide Field of View will really help shape how we implement our architecture moving forward and get after that threat. We are working with the Space Development Agency and the Missile Defense Agency in a combined program office to have an integrated missile warning architecture that will soon pivot away from GEO towards the MEO and LEO layers on orbit. The data from Wide Field of View will help pathfind and demonstrate what technologies we want to use in the future. Wide Field of View has a 4K by 4K focal plane. With this, we'll be able to see a larger area of the Earth than ever before, over 3,000 plus kilometers at any one time. It also has a tactical cryocooler, which has been used in the air domain, and now we're eager to see how it will be applied to the space domain. If this works, we can see significant cost savings as we scale up our architecture in the future. Another way that Wide Field of View is going to be helping us is with data exploitation. We're performing data exploitation out of our TAP lab in Boulder, Colorado, and the team there is really looking at how do we enhance our algorithms to really refine the battle space characterization and missile warning capabilities that we currently have. Wide Field of View is really going to help demonstrate that moving forward. It's also going to help us operationalize the data and get it integrated into the integrated tactical warning, attack, and assessment architecture that we're currently seeing with the SBIRS missions. We're very eager for the upcoming launch of SBIRS GEO-6, as it will be the second OPR spacecraft in a very short duration of time, really making our missile warning capability more robust than ever. We'd like to thank all of our mission partners and industry partners that have helped us to get to this point so far. Millennium Space Systems for the integration of the payload and the bus development, L3Harris for the payload, United Launch Alliance for helping launch our satellite into orbit, for the Space Dynamics Laboratory for the data exploitation and algorithm development, our partners at the Aerospace Corporation, and our partners at NASA Ames. Without all of them, this would not be possible, and we're very eager to see all the amazing capabilities that Wide Field of View is going to bring to orbit. Go Wide Field of View. We are a couple minutes away from MECO 1. While we wait, we thought it would be fun to share the results from the rounds of trivia we hosted earlier for our ULA Twitter account. Great job to all who participated and who were first to correctly answer each question. Okay, we're going to get into the trivia questions now. Question 1. Before today's mission, what was the most recent payload launched by an Atlas V 541 rocket? And the answer is ULA successfully launched the GOES-T Weather Observatory for NOAA and NASA in March from Cape Canaveral, Florida. Question number 2. How many U.S. national security launches has ULA performed in its 150 successful launches to date? And the answer for number 2 is ULA has launched 93 national security missions in our first 150 flights, deploying reconnaissance, communications, navigation, and weather satellites for the nation. Moving on to question number 3. How many burns by the Centaur upper stage are planned in tonight's USSF-12 launch? And the answer is USSF-12 launch is a direct insertion into geosynchronous orbit, one of the most challenging missions required by national security spaceflight. Atlas V will conduct 3 Centaur burns to reach its destination. Next question, question number 4. What is the diameter of the out-of-autoclave payload fairing protecting the dual USSF-12 payloads during launch? And the answer to this question is the 2 satellites riding into space atop this Atlas V rocket are protected during atmospheric flight by the 17.7 foot or 5.4 meter diameter out-of-autoclave payload fairing. And the final question, question number 5. What is the horsepower rating of the Atlas V 541 rocket launching tonight? And the final answer is The Atlas V 541 rocket unleashed 32 million horsepower to launch the USSF-12 mission to geosynchronous orbit.
And we have MECO, main engine cutoff.
Muy bien, en estos momentos se hizo el apagado de la segunda etapa.
Centaur is now entering a 12-minute coast duration. RCS is engaged 100% 4S settling as expected.
This is Atlas Mission Control at T+11 minutes and 21 seconds. Patrick Moore just confirmed successful completion of the first of 3 Centaur main engine burns. The second main engine burn will occur in approximately 12 minutes. During this time, I have the pleasure of being welcomed by Jason Kim, Millennium Space Systems CEO. Jason, thank you so much for being here.
Thanks for having me, Andrea.
Well, I bet you're really excited and
Voy a hacer un intento de hacer los primeros videos de recibimiento y dando curiosidades sobre misiones espaciales y serán curiosidades que tengan que ver con el sector aeroespacial real, como los sitios donde se hicieron las grabaciones y todo eso. Entonces sería todo.
Fantastic.
Y adiós.
Missile warning came